Section 1.6 The Design of Experiments. Lesson Objective: Describe the characteristics of an experiment. An experiment is a controlled study conducted to determine the effects of varying one or more explanatory variables, or factors, sometimes are called, has on a response variable. Any combination of these values is called a treatment. An experimental unit or subject is a person, object, or some well-defined item on which a treatment is applied. The control group serves as a baseline. In design experiment, we have a control group and we have a treatment group. The control group serves as a baseline treatment, so we can compare it to other treatments. The control group gets what's called a placebo, which is basically like a sugar tablet. It looks, it smells, and it tastes just like the experimental medication, but it has no medication in it. So, why do we need a placebo? Well, let's look at an example. Want to help balding men keep their hair? Give them a placebo. One study found that 42% of balding men maintained or increased the amount of hair on their heads when they took a placebo. This is an example of how the power of suggestion can trick people. Another study told that 13 people who were very sensitive to poison ivy that the stuff was being rubbed on one arm was poison ivy. In fact, it was a placebo, but all 13 broke out in a rash. The stuff rubbed on the other arm really was poison ivy, but the persons told it was harmless, and only 2 out of 13 developed a rash. When the ailment is vague and psychological, like depression, some experts think that about 3/4 of the effect of most widely used drugs are just the placebo effect, the power of suggestion. Others disagree. The strength of the placebo effect and the medical treatment is hard to pin down because it depends on an exact environment. So here's a visual of a design experiment with one treatment. We have a random assignment, and one group gets a treatment, the other is the control that gets the placebo, and then you compare the results from both groups. Blinding refers to the non-disclosure of the treatment an experiment unit is receiving. There's 2 types. A single blind experiment is one in which the experimental unit or subject does not know which treatment he or she is receiving. A double-blind experiment is one where neither the experimental unit nor the researcher in contact with the experimental unit knows which treatment the experimental unit is receiving. This means that the doctor or the person giving the medication to the person does not know if it's the placebo or if it's the treatment. So why do a double blind? Well, if the person who's giving the medication knows who's giving the real treatment or the placebo, they may be more prone to sway the results towards the treatment. The English Department of Community College is considering adopting an online version of the freshman English course. To compare the new online course to the traditional course, an English department faculty member randomly splits a section of her course. Half the students receive the traditional course, and the other half are given an online version. At the end of the semester, both groups will be given a test to determine which one performed better. Now, is this an observational study or design experiment? This is a design experiment because there's a treatment group and there's a control group. What are the experimental units? That would be the students in the class. What is the population for which this study applies? All students are enrolled in that English course. What are the treatments? The traditional versus the online instruction. The response variable is how well they do on the exam. And this cannot be done with blinding because, well, both the units and the instructors know which treatment they are receiving. In the baldness study, 42% of the placebo group kept or increased their hair, but 86% of the men getting a new drug to fight baldness did so. The drug beats the placebo, so it has something besides the placebo going for it. Of course, the placebo effect is still part of the reason this and other treatments work. Because the placebo effect is so strong, it would be foolish to tell students in a medical experiment whether they're receiving a new drug or a placebo. Knowing that they're getting just a placebo might weaken the placebo effect and bias the experiment in favor of the other treatments. It is also foolish to tell the doctors and other medical personnel which treatment each subject received. This is why we want a double-blind experiment. If they know that the subject is getting just a placebo, they may expect less than if they know the subject is receiving a promising experimental drug. Doctors' expectation change on how they interact with patients and even the way they diagnose a patient's condition. Whenever possible, experiments with human subjects should be double-blind. So if an experiment is always better than an observational study, why don't we always use an experiment? Well, sometimes it's unethical or impossible to assign people to receive a certain treatment. There's also time, money, and effort involved, and sometimes certain explanatory variables such as handedness or gender are inherent traits and cannot be randomly assigned. Here's the reading for section 1.6 and the suggested problems from the book to try. Thanks for watching.